All right, here we are, to infinity and beyond. Today's lesson, I am going to not write them out. I'm just going to have you fill them out as I talk. That will be easier for me, okay? So I hope you're listening. You should be listening right now. If you are listening, put a actual smiley right here and then some eyebrows. All right. Oh, don't forget a nose. All right, so here we go. We are going to talk about two different series. Remember, series is where we add up numbers. So if I'm actually going to look at this second one right here, talk about a divergent series. If I multiply by 3 every single time, so you can see my example here, these numbers are getting larger and larger. The numbers are approaching infinity. So therefore, when I add them all together, we are essentially just getting bigger and bigger and bigger and bigger, okay? This is not going to be the one that we're going to really focus on or have application with. I do need you to know it's a divergent series, and I do need you to know our R value is greater than 1. It says absolute value of R because we could be doing the exact same thing with negative numbers, right? And then if we have the absolute value of that being greater than 1, the numbers are just getting larger and larger. So essentially we are looking for not a negative R value, but an R value that makes us what you guys think is a fraction, like 2/3 or 1/2 or 1/3. And what happens here? Well, coming up here, we have ourselves a different one. We have a convergent series. A convergent series would be where we're multiplying by, as hopefully you can see, 1/2 here. But what's 18 plus 9? 27. Okay, great. But then if I add the next number, it's going to be half of that. It's going to be 4.5. And then I'm going to add half of that. And then I'm going to, if I continue to add a smaller and smaller and smaller and smaller number, the series is going to settle to a specific number. So here's a little bit of an example before we dive into the actual formula. There's our formula. It's very simple in application, which is nice. But if I asked you this, ready? Process the area of the square through the addition of the parts. So here's the deal. What is the area of the square? Let's just say it's 1 square unit, because no matter what it is, like meters, feet, whatever, it is 1 square unit, 1 unit squared. So let's just think about this. Well, could we add it up, just think about this, by saying, all right, well, half of it is right here. So looking over here, I'm going to say, all right, so we've talked about half of it. Well, let's add a quarter of it. So now I'm adding a quarter of that square. All right, let's now add an eighth of that square. I got an eighth added to that. Let's add a 16th. I got a 16th. And if we just if we keep doing this process, we will add 1 over 32, we'll add 1 over 64, we're approaching, hopefully you can see, we are approaching the area of the square. Now, theoretically, and hear me say that, theoretically, we could never actually finish this process because there's always a half. I know that blows your mind, okay? But there's always a half. So this formula takes that into account. Like theoretically, we should be able to finish this process. So watch how we would use this formula. So right here, the infinite sum is the left side, okay? You take the first term, which in this case is 1/2, and then the bottom is 1 minus r. So in our case, it's 1 minus 1/2. And you can see that this formula will give you the number as the area of the square, even though we actually could never do that. Why? Because back up here, it's a convergent series. It settles to the answer using that formula. All right, once again, I have the answers all there. Okay, try not to look at them. Have some self-discipline here. Example 2. The pendulum of a clock swings back and forth. Initially, so here we go. Here's the pendulum. It's going to swing back and forth. Initially, the pendulum swings through an arc of 18 inches. So our first time the pendulum swings, the arc is 18 inches. That's what that says. Okay, so it's going to be over here then. On each successive swing, the length of the arc is 95% of its previous length. So it's going to be here, and then here, and then here, and then here, 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 here. Okay, so that's the idea. Now, you can see pretty quickly that we have a first term of 18, and hopefully it makes sense that the R value is 0.95 because we multiply by 95% or 0.95 each time. So when they ask a question here, what is the length of the arc after 10 swings? Pretty straightforward. You are from the geometric sequence day, just doing our formula of you take the first term, you multiply it by the R value to the n minus 1, and if it's the 10th swing we're looking for, when we crank out this answer, 18 times 0.95, we get to the 9th, we get 11.34 inches. So this one, honestly, right here, we should have been able to do without today's lesson. Moving along. What is the distance traveled by the tip of the pendulum after 15 swings? Okay, so remember that part is, this is the tip of the pendulum. So in the first swing, it's 18 inches. But then on the next one, it's 95% of 18 inches. Then the next one, it's here. Then the next, and then the next. So what is the distance traveled by the tip of the pendulum? There is an arc on a circle here, but it's being traveled, right? So we have 15 swings. Well, this one up here told us how far it was after the 10th swing, right? So we just want to add up the first 15 swings. So that's a finite geometric sum. Okay, so now what do we got? We got our first term, we got that formula that we had before, 1 minus r on the bottom. Take a second, focus in on that. But when we fly all that in our calculator, the total sum for 15 swings, all of that distance together, is 193.22 inches. Okay, so now here's the new stuff. Today's, what is the total distance traveled by the tip of the pendulum when it has stopped? So again, we know that this process of 95% is not going to actually happen. It's not going to keep going for an infinite amount of time. The pendulum will stop. But what can we use in theory to come up with this answer? We can use our new infinite sum and just say, all right, we're going to sum up an infinite amount of swings here. Here we go. What does this number settle to? Because it's a convergent series. Take our first term, 1 minus r, which is 0.95, and if we kept this process up, you keep doing, sum of 30, sum of 45, sum of 80, it's going to be a number that's getting closer and closer and closer to 360. So 360 inches is what we declare as the answer to this question. All right, and then before I reveal the answer to this one, I do want you to look here at what we have. What we have here, I don't know how to get that off there, sorry. All right, what we have here, that's not a good, there we go, is the sigma. Sorry, stumbling here. I don't know why I'm all stressed out. You guys know me, we're good. Okay, so we start at 1 and we go to infinity. What? Infinity? How do we stop at infinity? I mean, kind of Captain Obvious here, but if we see that, we should know, well, we're going to use this infinite sum. Well, just remember that we just had on the other side here, the infinite sum is the first term over 1 minus r. So from this information, you got to be able to find the first term and the r value. And if you can do that, then you can answer this question. All right, well, what's our first term? Well, we put in a 4 times 1/5 to the 1 minus 1. Well, once again, that's just going to be 0. Anything to the 0 is 1. So our first term is 4. This is in perfect form for us to be able to see that the first term is 4. And then our r value is 1/5. Remember, whatever is here, that's that base of our exponential property. So we have it as our r value. So when you look at this formula, 4 over 1 minus 1/5 equals 4 divided by, this is really 5 over 5. Right here, 5 over 5 minus 1/5 is 4/5. Multiply by the reciprocal, we are going to get an infinite sum of 5. All right? Okay, so hopefully this plants the seed of you being able to, work on problems that are infinite. But also, in your practice, anytime it's a finite series or just asking for a sequence, it's all going together. So give it a try on worksheet number 7, and we will reboot on Monday. Have a great weekend.